So in the last section, we learned how to solve quadratic equations that couldn't be factored using the completing the square method. Now this is really handy, especially when we have quadratic equations that can't be factored. So what mathematicians tried to do, or what we're going to try to do today, is find a way to solve quadratic equations that can't be factored for any quadratic that's in this standard form. So if we have ax squared plus bx plus c, we can actually use the completing the square method to find an equation that solves for x. So all right, to kind of show you how the general form relates to a real example, I'm going to do them side by side. So in completing the square, what are we going to do to this first? We're going to divide everything by 2. So you have x squared plus 14x plus 25 equals 0. And so we're going to do the same thing over here. And a is just a number, so we can divide everything by a. All right, and then over here, we want to get this over to the other side. And we know that we're going to add something to both sides. And so one thing I like to do is add a plus and then a blank. So over here, x squared plus b over a x plus blank equals negative c over a plus blank. So what are we going to add to both sides here? Well, we take this middle term, 14 over 2, and we square it. So 14 over 2 is 7 squared is 49. So you add 49 to both sides. Then over here, we're going to do the same thing. We're going to take b over a over 2 squared. But this is just the same thing as b over a times 1/2 squared, which is b over 2a squared, which is b squared over 4a squared. So that's what we're going to add to these sides. All right, we don't need these anymore. All right, so now we can write this as a square. So x plus 7 squared equals 49 minus 25 is 24. And over here, we can do the same thing, right? X plus b over 2a, it looks like, squared equals. And so to combine this, we need to get a common denominator. So that's negative 4ac over 4a squared if we divide both of these by 4a. So b squared minus 4ac all over 4a squared, which is our common denominator. So in this example, we take the square root of both sides. Make sure to make this plus or minus. So we have x plus 7 equals plus or minus the square root of 24, which, if we're going to simplify this, we turn it into 8 times 3, which is 4 times 2 times 3. And in the next step, I'll reduce that down. So then we take square roots of this side over here, just like we did back here. So x plus b over 2a equals plus or minus the square root of b squared minus 4ac over the square root of 4a squared, which is just the same thing as everything underneath the square root. So the 4 is 2 squared, so we can bring a 2 out of this radical. But first, let's subtract 7 from both sides. So x x equals negative 7 plus or minus 2 times the square root of 2 times 3 is 6. So over here, we're going to do the same thing. Subtract b over 2a from both sides. So x equals, well, negative b over 2a plus or minus the square root of b squared minus 4ac over the square root of 4a squared. Well, 4a squared is a perfect square, so you can write 2a. These two things happen to be common denominators, so now we can rewrite this as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is our quadratic formula. And so we can use this equation given any quadratic equation that looks like this to get values for x. All right, so now I have a couple examples. All right, so here we have 3 examples. So let's try to solve these using the quadratic equation, which again is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you'll have to memorize this. If you look on YouTube, there are plenty of songs that you know, have rhymes and such to help you remember this. So anyway, plugging this in, what's our b value? The b value is what's ever in front of this x, and so there's an invisible 1 there. So let's plug in negative 1 plus or minus the square root of 1 again squared minus 4 times the a value, which is in front of the x squared, which is 1, then c, which is negative 4. If that's under the square root, then all of that is over 2 times the thing in front of the x squared is 1. And so, same thing as negative 1 plus or minus the square root of 1 plus 16, which is negative 4 times negative 4 over 2. And then that is negative 1 plus or minus the square root of 17 over 2. And if we're going to write this as 2 different solutions, we just break up this plus and minus. So we can write negative 1 plus the square root of 17 over 2 and negative 1 minus the square root of 17 over 2. All right, so let's move on to this example. Same deal. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Right, so x equals negative. Ooh, this one has decimals, but don't worry, the quadratic formula will still work. 1.2 is what's in front of the x, plus or minus the square root of b again, 1.2 squared minus 4 times the thing in front of the x squared, which is 1, times c, which is 0.36. All over 2 times 1. So, negative 1.2 plus or minus the square root. 1.2 squared is 1.44. And then 4 times 0.36 is also 1.44 all over 2, which is negative 1.2 plus or minus 0 all over 2, which is the same thing as just 1.2 over 2, because when you add and subtract 0, you get the same thing. And so when we divide that, we get x equals negative 0.6. All right, and one last example. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the thing in front of the x, negative 2, plus or minus the square root, negative 2 again, squared minus 4 times 3 times 1, all over 2 times 3 in front of the x squared now. X equals 2 plus or minus the square root of negative 2 squared is 4 minus 4 times 3 times 1 is 12, all over 2 times 3, which is 6. So then x equals 2 plus or minus the square root of 4 minus 12, which is negative 8, all over 6. Now, remember a couple sections ago we talked about I, which is an imaginary number that equals the square root of negative 1. And what we can do when we have this negative underneath the square root is we can pull out an I, and the negative underneath the square root goes away. And so this can turn into x equals 2 plus or minus the square root of 8i all over 6. Right. And then just to do some simplification, that's 2 plus or minus, that's 4 times 2, so a 2 comes out, 2 times the square root of 2i all over 6. We can factor a 2 out of this, so that's 2 times 1 plus or minus the square root of 2i all over 6. Whoop, that turns into a 3. So x equals 1 plus or minus the square root of 2i all over 3. And again, because we like to write it as two solutions, 1 plus the square root of 2i over 3, and 1 minus the square root of 2i over 3. Now, sometimes, technically, complex numbers are in the form a plus bi. And even though these are technically correct answers, they're not in this form. So depending on your instructor and your whatever form you're doing homework on, like I know some online programs like you to use a plus bi. And so, but we can rewrite this as just 1 over 3 plus root 2 over 3i, then 1 over 3 minus root 2 over 3i, which is in the complex number form a plus bi. So, notice that we have 3 different kinds of solutions. We have one where we have 2 real solutions. This one has 1 real solution. And then this has 2 complex but not real solutions. All right. Well, it turns out that we can predict which of these 3 types our quadratic equation will fall under. So we can tell just from this formula whether we're going to have 2 real solutions, 1 real solution, or 2 complex but not real solutions. And the way we do that is from a specific part of the quadratic formula. This part, underneath this square root, is called the discriminant. Right? And it's equal to b squared minus 4ac. So if you notice in this example, our discriminant, we had b squared minus 4ac, and when we did it out, we got a positive number. Right? And when we did it here, we got 0. Because 1.44 minus 1.44 equals 0, and the square root of 0 is 0. All right, and then over here, we got a negative number. So using this information, there's something called the discriminant test. So to summarize it, when the discriminant is when it's positive, we're going to have two real solutions. When it's 0, we're going to have one real solution. And when it's negative, we're going to have two complex but not real solutions. Right. And if you think about this graphically, when we have a positive discriminant, just as an aside, when we graph a quadratic, it looks like a parabola. And so if we have two solutions, it's going to intersect the x-axis twice. When the discriminant is 0, we have one real solution. So we know that it intersects the x-axis only once. So it's going to look something like this, where it just touches the x-axis. Then when it's negative, it doesn't have any real solutions, so it doesn't touch the x-axis at all. So it'll look something like that. Right?